to show that Reynold number is equal to 0.5134 times pressure at standard condition divided by temperature at standard condition times the gas gravity times flow rate at standard condition divided by the viscosity divided by internal diameter. So where the base pressure, which is the pressure at standard condition, is in kilopascal, the base temperature, which is the temperature at standard condition, which is in Kelvin, the gas gravity, which is G, dimensionless, the flow rate, which is gas flow rate, standard condition, the P, which is the pipe inside diameter, millimeter, um, mu, which is viscosity of the gas in parts. Now let's work it out. So we also know that the Reynold number is equal to the density times velocity times internal diameter divided by the viscosity. Now we also know that flow rate is equal to the velocity of the gas times the cross-sectional area. And since it's a cylindrical pipe, the area is equal to pi d square all over 4. Now substituting that, we also note from this equation, let's say this is equation 1, equation 2. From equation 1, from equation 2, the velocity of the gas is equal to the flow rate divided by the cross-sectional area. Now, substituting equation 3 into equation 4, you have velocity equal to 4 flow rate divided by pi d squared. This is equation 5. Now, substituting equation 5 into equation 1, we now have Reynold number equal to density times the velocity, which is now 4q all over pi d squared times t divided by mu. Now, to rearrange this, you have density times 4q times d divided by pi d square mu. So this, to cancel out this, you have 4 density q all over pi d mu. Now we have this expression for Reynold number. So we have 4 density times flow rate divided by pi d mu. Again, according to the law of conservation of mass, if a gas is flowing from here, the amount of gas entering into a pipe is equal to the mass of gas entering into a pipe is equal to the mass of gas leaving that pipe. So let's say this is section 1, this is section 2. Now that means the mass flow rate of gas entering a pipe is equal to the mass flow rate of gas leaving a pipe, provided there is no other injection or discharge from that same pipe. Maybe there is no leak along the pipe. So the mass entering, the mass flow rate entering and the mass flow rate leaving will just be the same. So that means the mass flow rate for section 1 is equal to the mass flow rate for section 2. And mass flow rate is equal to density. Sorry, the mass flow rate is equal to density times flow rate. Or we say density is equal to the mass flow rate divided by the flow rate, which if you rearrange this, you now see that the mass flow rate is equal to density times the volume flow rate. And again, if a gas is trapped inside a container at any condition. If you change the condition to standard condition, the mass of gas inside that condition will still remain the same, provided there is no um, gas leaving or entering. So that means the density of gas times flow rate at any condition is equal to the um, is equal to the density of gas at standard condition times the flow rate at times the flow rate at standard condition. Let's say in this section of the pipe, let's say we just circle a region and gas is coming in and also leaving. Let's say gas is coming in here and also leaving. Let's say this one is at any condition. Now, let's say you have a gas is coming into the system and also leaving into this. So since the flow rate coming in and the flow rate going out is the same, inside this region, the amount of gas inside this region will still remain the same, provided there is no gas going out from any other section, just from here. So the amount of gas inside this section remains the same. So that means the at any given condition, the mass of gas remains the same. So that is the same expression. Now we have gotten that the density of gas at any condition times the flow rate of gas at any condition is equal to the density of gas at standard condition times the flow rate of gas at any condition, which is the conservation of mass. So the law of conservation of mass. So that means this expression here, let me call this equation 6. So from equation 6, we have Reynold number equal to 4 times the density of gas at any condition times the flow rate of gas at any condition divided by pi divided by density divided by mu. So this is also the same thing as 4 times density of gas at standard condition times also the flow rate of gas at standard condition divided by pi divided by d divided by mu. Since pi d and viscosity of the gas remains constant, so this whole thing will remain the same. From this expression from equation 7, it also shows that the density of gas at any condition times the flow rate at any condition is equal to the density of gas at standard condition times the flow rate at standard condition. So that means this is also equal to this. So now Reynold number is equal to 4 times the density of gas at standard condition times the flow rate at standard condition divided by pi d mu. Now, applying real gas equation where you have the product of pressure times volume is equal to mole, number of mole times Z times R times T. Now, we also know that P times V times is equal to, we know that the number of mole is equal to the mass of the gas divided by the molecular weight of the gas times Z times gas constants times temperature. Now, this also, so we are looking at we want to look for the density of gas at standard condition in terms of pressure and temperature. So we also know that density is equal to mass all over volume. Now, from this equation, Dividing both sides by volume, you have pressure equal to mass of gas divided by the volume of gas divided by the molecular weight of the gas times Z times gas constant times temperature. Now, now for standard condition, you now have PB equal to mass all over volume is density. So density at standard condition times gas compressibility constant compressibility factor at standard condition times gas constant times temperature at standard condition divided by molecular weight of the gas. So you now have pressure pressure at the that is pressure, the base pressure, which is pressure at the standard condition, equal to the density at standard condition times Z, that is the compressibility factor at standard condition times gas constant times temperature divided by the molecular weight of the gas. So now making density the subject formula, we divide both sides of the equation with this. So dividing both sides of the equation with the whole of this expression, you have density equal to the pressure at standard condition times molecular weight divided by Z at standard condition times gas constant times um, divided by temperature at standard condition. So now with this whole expression, we can now reduce this thing further since the compressibility factor at standard condition is approximately equal to 1.0. We now have density at standard condition equal to the pressure at standard condition times the molecular weight of the gas divided by gas constant divided by temperature at standard condition, which is the base temperature. Now, we also know that gas gravity is equal to the molecular weight of the gas divided by the molecular weight of air. Since the molecular weight of air is equal to 29 grams per mole, then the molecular weight of gas is equal to 29 times gas gravity grams per mole. So substituting this into this equation, we now have that the density at standard condition will now be 29 GPP all over RTB. Now substituting this density into into this equation into this equation now, where you have Reynold number equal to 4 density times the flow rate divided by pi d mu. Now substituting this equation into this, you have 4 brackets open 29 GPB divided by RTB times QB divided by pi d mu. So that means Reynold number is equal to 4 times 29 times PP divided by TB divide by pi d mu r times the flow rate. Now, so Reynold number, you have 4 times 29 times, you now have times QP divided by pi d times mu times all divided by pi times d times viscosity of the gas times gas gravity times the pressure divided by the temperature at standard condition. So you will now have 4 times 29 QB divided by pi d mu r all divided by this times PB all over TB. So let's go to the next page. We have 4 times 29 times QB divided by pi d r mu times PB all over TB as the base pressure divided by the base temperature. So you have 4 times 29 times the flow rate is in meter cube per day. So times, now we need to change this day to seconds. So now we know that 1 day is equivalent to 24 hours. Now to change this hour to minutes, we know 60 minutes is equal to 1 hour times, we need to change this minute to seconds. So 60 seconds is equal to 1 minute. Now times, we know that the pressure is in kilopascal, and we also know that 1000 Newton meter square is equal to 1 kilopascal. So divide by 4 times, okay, not 4, pi, divide by pi, divide by the internal diameter, which is in millimeter. So we also note that we now need to change this millimeter to meter. So 1 meter is equal to 1000 millimeter times, this is pi, sorry, this is pi. We also know that the Reynold number is equal to 8314.598 grams per meter square, sorry, grams times meter square per second square per mole per Kelvin. So times mu, which is viscosity of the gas, is in pulse. We also note that 0.1 Newton seconds per meter square is equal to 1 pulse. So when you take kilopascal, will cancel this kilopascal. 1 pulse cancel 1 pulse here. Millimeter will cancel millimeter here. A day will cancel day here. You have hour will cancel this hour, minute will cancel this minute here. We are left with this whole thing remaining now. So we have, what is left now? Okay, now let's look at this. You have meter square, we'll cancel out the meter square here. Now this is 29. So 29, there's G here, sorry, there's G. So we have 29 G mole. So this will be the whole of this 29 gram. 29 G will be mole per gram per mole, sorry. So this gram per mole will cancel this gram per mole here. And 1 seconds here will cancel 1 seconds square here. Now here up here we have meter square will cancel 2 meter square here, remaining 1 meter here. Here is remaining seconds. So you see there's G here, so there is also, I didn't put the G because there's G here. The G should come here, G here, G here. So let's why there's G there. So now we have this one. Now Reynold number will now be 4 times 29 times this is 1000. This divided by the whole of this, which is 24, divided by 60, divided by 60. That's the whole of this. Divide by this pi, divide by 8314.4598. Now divide by 1000. Sorry, this 1000 will come up. This is all over 1000, so this one will be 1000 square. So divide by this, which is 0.1, divide by 0.1, so times, you have up here to be G times Q B divide by D mu times, now there is Kelvin here, this temperature in Kelvin, and then put it, okay, let me say temperature in Kelvin. So this Kelvin will cancel out this Kelvin here. This Kelvin here will cancel out this Kelvin here. Now, if you look up the units up here, you have Newton, we have meter. So we have Newton meter per seconds that is remaining up there. So down you have Newton remaining here and meter. You have seconds remaining here. So you have Newton meter per second. So this will cancel out. So now up here we have pressure divided by temperature. So now we are now left by calculating this whole thing to see. Now let's get our calculator. Times 29 times 1000 square divided by 24 divided by 16 divided by 16 divided by 0.1. This is 0.1 divided by 8 divided by 8314.4598 divided by pi. This is pi. Divided by pi equal to, so the whole you have 0.513996. So the whole of this constant now is, so Reynold number is equal to, will now be equal to 0.513996 G times Q standard condition, we divide by mu B times pressure as standard condition divided by temperature as standard condition. So this is the end of this whole thing. So now what we got is 0.5140 times G QB divided by mu D times PB all over TB. So this is our final answer. So if you look at it, it's similar to, same as 0.5134 GQB all over mu D times PB all over TB. So thank you for watching to the end. Have a nice day. Also do well to subscribe to my channel and hit the notification bell, so each time I make new video you will be the first to watch. Thank you and God bless.